Hello everyone, I'm me. I am a student in K67K class, Faculty of Physics. Okay, today we'll present about my teaching plan, physical law in optical physics, refraction law. Yes, it is in the credits. Use experiment in physics education of mutation by chip. Okay, start now. We will start now. Firstly, my presentation will have 4 parts. Firstly, enactment. Yes. I give some situation and ask students some problem. Secondly, exploration in order to answer the problem. We get some deduction process. Yes, and these are experiment. Yes, to investigate, to answer, to do something. Just explanation. We take the data analysis and get the conclusion, and elaboration is final. And I give my students some challenge problem in order extend the knowledge. Yes. Okay, we will come to the part 1 is enactment. Firstly, I will show my student this picture. The pen looks broken. This is the wall half is to and I will ask some student what is phenomenon. I hope that someone can remember. They have already learned in grade 9. Grade 9. So if they don't remember, I can recall a concept. It's a refraction phenomenon, refraction of light phenomena. And we will go to the its definition of refraction of light. Yes, the change of the direction of light when it enters or leaves a material transparent equals refraction phenomena. Yes. And you can see that. The is this here when the it is not straight line, the pencil in a straight line. Yes, not straight line. When it enters when the pencil enter the interplay between the two medium is gas and it is water. The ray of light is bent. Yes, my student have already know that in grade 9. Yes. In order to present it clearly, I will give them some from the diagram. Yes, this is diagram. Here. It is air, the first medium air, the second medium glass. Yes, we will with normal. No, what is normal? Normal is plane that's perpendicular to the interface between two medium. At what? At that point, that's the radiant enter the second medium at this point. Yes, and we got the incident, we got the incident right, and we got the refracted square right, and we have a angle of incident, and the angle of refraction. Angle of incident is the angle between the incident right and normal. It's also for the refraction. It is an angle between angle of refracted ray related to the normal. Yes, it is angle. So we know that the relative position of incident ray and refracted ray is they are on the same plane. What plane? This plane is a plane created by the incident ray and the normal. Yes, but when we mention in the angle of incident and the angle of refraction, what is the relationship? Yes, what is the relationship? Yes, and how can we know the relation? And if we increase or decrease the incident angle, what happened to the if we increase or decrease the angle of incident, what happened with the angle of refraction? Yes, and what? Yes, we will focus on this lecture to answer some question here. What is the quantitative relationship between the incident angle and refracted angle? And secondly, how does the incident angle depend on the refracted angle and vice versa? Yes, we will go to the part 2. Yes, part 3 explanations. Firstly, we will some deduction. Yes, if I will got a statement, if we increase the incident angle, what happened to the refracted angle? There are some students they can say that it's also increase. Yes, it's also increase. Yes, the refracted angle will increase also. So when the incident angle increase, the refracted angle increase, and maybe the value observed are directly proportional. Yes, and we get reason that the relationship between them is directly proportional, or I over R equal constant. Yes, what is I? I is the value of the angle, incident angle, and R is value of refracted angle. But there's some student may not know when we increase the incident angle, the refracted angle maybe decrease. Why? Yes, and also for the first case we can get the prediction that I term as the product of I term R, it may be a constant. It represents the mathematical relation. Yes, and the physical relation, physical significance as when the refracted angle and the incident angle are inversely proportional. Yes, this is a prediction because of deduction, theory deduction. So next we will go to partial experiment design. Yes, firstly apparatus. In this part we got, yes, we can answer how many components of this experiment setup, what are they, and how they look like, what is function of each component, how the components are connected together. Yes, and secondly procedure step by step. First step, second step. Secondly, what we must do. Yes, Second, and finally, its outcome. We answer the question: does the result agree with the prediction or not? Yes. Firstly, go now. Operators firstly is paper eliminate. What is paper elimination? Is use a protractor to measure the angle. In this case, it measures the incident angle and the refracted angle. Like a lamp with the power with the voltage is 12 and the power is 10 watt. Yes. Monochromatic light increased by the laser lamp. Yes, it means that lamp is a light of source. Yes. Semicircular slab. What? Semicircular plate role as a second medium, transparent medium. In this case, it like a glass. Yes. And finally, conducting wire. Why we must have a conducting wire? Yes. Is for conducting wire have a plug at one end, and they are used to connect the lamp to the power supply. The lamp equals so whenever it is connected with the power supply and we turn on the lamp, then we will the monochromatic light will be icy. Yes, will appear. Yes, it is a figure of our the experiment setup and so on. Yes, it is paper laminates the lamp, circular slab, and conducting wire. Next is the procedure. And yes, what we have to do in the first step, second step, and final step. Yes, okay. Yes, firstly, step by step. First step I call is first I call is a prepare step. Yes, lamps must be connected with the power supply in order to lamp is already to work. Yes, and put the sensor of a projector at the band point of the C plate with two medium. In this case, two medium is the first medium is air and the second medium is glass. Yes, that's it. Second step, turn on the lamp. Okay, that's alright. And the side a light beam from the air to the sensor. Yes, this air and this inside the projector is semicircular slab. Yes. Obvious the dimension of incident light. Yes, incident light and refracted light. And record the value and give them data. And in this case, the incident angle is the incident between incident right and the normal is normal. And it is the angle between the refracted right and refract and the normal. Yes, yeah. And in this case, the incident angle maybe approximate to the 40, and the refracted angle must be okay 25 degrees. Yes, and we must be repeat the experiment in some several times. Change the angle, we maybe degree or increase the angle. Yes, incident angle. So what happened with the incident with the refracted angle? We will record them, give them in the table data table. Yes, sir. And after some several times we repeat the experiment, we got the data value. Yes, 1 2 3 4 5 6 7 times. Yes, 7 times. It is a value of angle and is the value of incident angle. And is the value of refracted angle, and we got the product, and we got the ratio. Yes, the product of I and R. Wow, it's crazy. Ratio of ratio of I và maybe increase. Yes, it is not constant, so it is the outcome, the result doesn't agree with the student prediction. I'm sorry, my student is not correct. Yeah. Oh, so at this moment, the student are being confused. So I will help them. I will give them a suggestion. Yes. Yeah, as you can see that when the incident angle increase, the refracted angle also increase, but it is not linear relationship. So I suggest them to present the relationship with a mathematical function of I and R, like sin a sine function. Why? For two reasons. Firstly, sine function in a trigonometric function of angle, and the secondly, sine function is a monotomical increasing function in the domain 0 to the 90 degree. Yes, because it is very suitable with the result that we got in the previous table data. So after that, my student will interpret. Yes, here we go. We got the new data table. Oh, let's see. Let's obvious this column. Wow, it's awesome. The value are approximate equal each other. Yes, with small error. And we can conclude that sine of incident angle over sine of refracted angle equal here, and maybe equal a constant with very small error. So we can conclude that the ratio of sine I over sine R is constant, not I over R is constant, or I, the product of I and R, are constant. Yes, we got the result for our prediction. Yes, and the result for the problem of this lecture deploys. Yes, and we got the ratio is constant, so we success that we have new concept of physics, of optical physics. As here, yes, and I will give them data that is a refracted in this, and it knows why, and it is new concept of and this is the first time I have ever told to my student. It's new concept. It must be sub, and I got the conclusion for this lecture about the refraction law. Yes, firstly, yes, and you can see that. Firstly, for a certain transparent medium, the ratio of sine of the angle, incident angle, and the sine of the refraction angle, the refractive angle, E, constant. And this relationship is presented by the formula of Snell-Descartes law. Snell and Descartes are true scientists. They are independent. Discovered this law in optical physics. Yes, where n is the relative index of the refraction of two media, and in this case is a ratio of index in glass over in refracted index in the refractive index in the glass in the air. Yes. Moreover, what we will define for new concept refractive index. Refractive index or index of refraction of a certain material in a dimensionless number that requires how fast light travels through the material. Yes, the more refractive index, the slower light travels through the material, and it defined here. And equals c over v, where c is speed of light in the vacuum or in the air. Maybe approximate the speed of light in the air, and v is the phase velocity of light in a certain medium. Yes. Now we go to the part 4, elaboration. As here I will give my student some challenge problem. Yes, they will apply the knowledge of refraction law in order to solve this problem. Yes, solve or explain or do something. Yes. First problem is here. A pair of toy cars are rotated indirectly from a smooth surface onto two plots of grass. The rectangular here and triangle here. Yes. Ground is a line incline. After slowing down is grass. Yes. Is here in a straight line. It doesn't move in a straight line. Maybe it's something. Yes. Slowing down in grass. Yes. The wheels will speed up. Okay. After the wheel travel in the grass, the cars will speed up again and imagine a smooth surface. As finished, I asked my student to trace cat by showing some position in here or in here of the wheel inside plot, and another. If my student got difficulty to solve this problem, I will give them some hints. It's such as the index, the refracted index, or this problem, or they can imagine this problem such as yes. A. Yes, it is a smooth ground. It's a grass. Yes, and after that the cat emerged the grass. Yes, it similar to this problem. Yes, we can relate from the knowledge in this lecture. Yes, to solve this problem. Yes. Okay. Next, the second problem here. Okay, I will give my student. To solve video. Sorry. Yeah. A video and ask them to explain why. Also using the knowledge about refraction law, and yeah. is also a prepare process. Okay. Next step, withdraw the create arrow. Okay. It's awesome physics. It is awesome physical experience. Okay. So it is easily to observe the phenomena. Yeah. Yes, after that we pour the water on the bottle, on the glass. I ask my student see the video carefully. Yes. There are no effect. What? Add more water. And what happened? What happened here? Okay. I will ask my student to explain this phenomenon. Why the direction of the arrow are inverted? Yes. Okay, we're moving on with my slide. Yes. Okay. If they got some difficult, I can give them some hint. Firstly, they can imagine they can recall the knowledge about the property of image of an object produced by a lens, and about the concept of flash spray between two different material, and can draw a diagram to easily to understand, easily to imagine what happened. Okay, that's all for today. Thank you for your listening. Thank you.